Inductors as a component in a DC circuit. An inductor is an electrical component that stores energy in a magnetic field when electrical current flows through it. Inductors are typically composed of a coil of conducting wire wrapped around a core, typically made of ferromagnetic material. However, some inductors consist of air cores. Inductors are used in circuits to slow down the flow of current by temporarily storing energy in an electromagnetic field and then discharging it back into the circuit, similarly to how a capacitor stores and discharges energy through an electric field. Inductance is a property of an inductor that determines how much it opposes change in current through storing energy in a magnetic field. To calculate inductance, many factors must be known. The number of turns of the coil, N, the coil's size or area, A, and the length of the coil, L. Furthermore, the permeability of free space is a constant which is applied in the formula for inductance. Ultimately, the resulting inductance is given in the SI unit, Henrys, H. The Henry unit, as defined by the Smithsonian Institution archives, is the induction in a circuit when the electromotive force inducing this circuit is 1 international volt, while the inducing current varies at the rate of 1 ampere per second. There is 2 relevant laws in the understanding of inductors. Faraday's law states that the electromotive force, EMF, induced in a closed circuit is directly proportional to the rate of change of magnetic flux through the circuit. Lenz's law describes the direction of the induced current in a closed loop. It states that the induced current will flow in a direction that opposes the change in magnetic flux that produced it. Lenz's law is often expressed as the negative sign in Faraday's equation, indicating opposition of direction. To add inductors in a circuit, whether series or parallel, to determine the total inductance in a particular circuit is obtained through the formulas as seen. Similar to resistors, inductors in series are simply added together to find the sum, and in parallel, the inverses of each inductance value is added and then inversed. A time constant is pivotal to determine a circuit which contains either inductors or capacitors measurements. As an inductor discharges current over time, varying values of current and voltage are seen. Integer values of time constants are often used to represent timestamps of the circuit displaying voltage or current values. Tau, the Greek letter, is used to represent the time constant in an inductor circuit. One time constant is obtained by dividing the total inductance by the total resistance, and the resulting value is given in seconds. As an example, the formula for current at a certain time period is as seen in the black box, which calculates the current after a period of the inductors discharging. An inductor acts differently in a DC circuit to how it does in an AC circuit. Initially, the inductor has high resistance and slows down the flow of current in the circuit as it's charged in its magnetic field. This results in high levels of voltage. When the inductor reaches steady state after usually 4 time constants, the inductor acts as a short circuit and does not oppose the flow of current, resulting in a peak of current. The voltage also drops to 0 as no energy is being released. When the power source of the circuit is turned off, the inductor again opposes the flow of current, and the discharging magnetic field induces a voltage in the opposite direction, as stated by Lenz's law. This creates a spike in voltage.